I do have the pleasure of introducing a colleague of mine, an appreciated colleague of mine, Rami Ben-Ari, Dr. Rami Ben-Ari from OriginAI. Rami is a senior researcher. He's also an adjacent professor at Bar-Ilan University. He's got his PhD from Tel Aviv University, and he's published more than 50 or something, 50 research papers. Thank you, Rami.
Hello, I'm Rami Ben-Ari, and I'm from OriginAI. I'm going to present mainly two recent papers that we published in AAAI and EURIPS. This is a collaboration with Dvir, Samuel, and Matan Levi, who are PhD students at our lab, one from BIU, Bar-Ilan University, and from Hebrew University, and also Boaz Lerner and Nir Darshan. The topic of my talk is chat-based search and generative-based search. So, what types of image retrieval exist? We all are familiar with the type of text-to-image where the user describes the image that he or she is looking for, and then retrieve the target image. The other type of modality input is image, and this is called the content-based image retrieval. The input is an image. Again, the user is looking for similar images in a large corpus that could be millions of images. The third type is bimodal, using an image and kind of a description that describes the change in the image that the user is looking for, again, to retrieve the relevant images out of that. This is related to a paper we published recently in AAAI, and I'm not going to get into this one. So what's next? We thought about this, and we came with a trend these days, this chat image retrieval that I'm going to describe. This paper was, this work was published in the last EURIPS in the United States. So what's the idea about? The idea is the user has some kind of a description or an image in his mind, and he just writes the description, a traffic light in a yellow, it's too small. A traffic light is in front of is kind of a house, and what is get when the traffic light is emphasized, we get these top ranks, and we can see that the image, the relevant image, is way down in the list in the rank over 1,000. Then the system, actually the AI system, asks some more questions. Where is it located, and what color is the house, and so on and so on. And the answers provided by the user are accumulated, and these question and answers that we call dialogues are then inserted into the system, and actually helping to get to the target images, as we can see over here. So how do we map a dialogue to an image representation? So the idea is to train a dialogue. So if you have a kind of a dialogue that is related to the image, we can train it like a clip in contrastive learning. We just concatenate those questions and answers with a CLS token, and we are done. But what's the data set? What data set can we use? So for this purpose, we used what's called the visual dialogue that was initially designed for another task. It's a kind of a visual question answering, but from a dialogue. But the idea there was to answer a question around the dialogue and an image, but we used it for this chat-based image retrieval. So we have dialogues, we have image, we can train our encoder. So we're done with this. So now how do we generate the questions? For that, we use a large language model like ChatGPT. And to this end, we just use the phenomenal, actually, the few-shot instructional setting in these large language models. We just give some examples with a description of the task, that the dialogue, the next question is aimed to help us to help the user to find an image in a corpus. And then we give him some examples. These examples also driven from the visual dialogue. And then the system will come up with a follow-up questions. So now we have the trained pipeline, we have the question generator, and we need to evaluate the system and see how well it works. The problem is that requires a human in the loop. The human is going to provide the answers. So what we do, we just replace it with a visual question answering engine like Blip 2, and we actually have now the pipeline. So now we tested it in the zero-shot text-to-image retrieval. We compared it to Clip, to Blip, and to the chat IR. Here you can see in the x-axis the dialogue rounds. As we go on and we add more and more dialogues, the retrieval performance is improved. So we tested it on Coco and Flickr, and we can see that chat is beneficial. Dialogue improves retrieval. Learning to encode dialogue is better because our encoder, chat IR, encodes actually the whole dialogue. So you can see more details in the benchmark. Here is another example of an airplane flying in air. So we can see that there are lots of airplanes in the data set. But if you go on and add more, as the system actually asks more questions, and the last one is the train where the airplane is flying over, and when it actually the answer is forest, we can see that the relevant images are then driven out. So this was the first topic, and the second topic I'm going to talk about is the image retrieval from images or text input, or both of them. Most of the literature is working on representation learning. We had a work that discussed multiple query images, because this is going to be a good cue or helping the system to find the relevant images. And what we are using today is the generative models. So this is related to the two recent papers that we had published recently in this domain, and I'm going to talk about it shortly. So how this retrieval with image generation system works: you have a query image, you have a query text, it goes into a generator engine. So we get more examples of the user intent, of the image that the user is thinking about. We just pour them into the retrieval machine, so we have now more examples, and that improves the retrieval performance eventually. And here is an example. We use a stable unclip. The user just pushes the button with a description of the image and sample images given by the user. We can generate more and more realistic images of that example, and eventually we can benchmark this process on data sets. We have here the places and few shot object detection. These are performances over 50,000 images in the corpus, and we can see that generative generation helps the retrieval performance. And for the last, I'm going to talk about a new model that we have developed. Can a diffusion model generate any object? And the answer is no. We found that there are certain objects like oxygen mask, payphone, and so on, that the stable diffusion really struggles with generating them correctly. And we can see that these images are actually the rare images in the corpus of the training set of diffusion models like Lion 5B and so on. So how can we correct this? So in order to correct these, and if a rare image is required, we just provide the system with several sample real images. We just inverse these images into the seeds, and we optimize over the seed, forwarding back the seed to the image space, and using the semantic laws and appearance laws, we can just correct the images and create realistic and good images from those rare subjects. We test it on clip view shot image recognition, and we see that we perform much better because those rare images are hard to create, and other methods fail. There are many more benchmarks in the paper that you can look. That's it. Thank you for your attention.